we're going to start with this topic. This would be the first topic in chemistry that we are going to see. And we're going to start with the very easy question, but very important question that says, what is chemistry? Chemistry obviously is the science that we're studying right now, right? But what is the scope of chemistry? So let's see that. It says chemistry is the science that deals with the properties, the composition and the structure of the substances, the elements and compounds, the transformation they undergo. So we're talking about chemical reactions and the energy that is released or absorbed in the process. Whenever we have a chemical reaction, you know that you either put some energy in it in the way of heat, in the way of temperature, an oven, etc., or you do something for that energy that is produced to not explode or go anywhere, right? Like, for example, when you have ice baths for the products of your reaction. Chemistry is not concerned with the subatomic domain, but with the properties governing the combination of them and how they react. So when we're talking about chemistry, it's not about how it is formed per se, but more of what we can combine with what in order to have some reactions. Remember, if we have this, we have the properties, the composition, but also the transformation they undergo. So it says chemistry is concerned with how we use natural substances and how we can create artificial ones. So we have here some examples of old substances and processes. We can see fermentation, how we make yogurt, how we make beer, how we make wine. That is a super old process. Glass making, how we go from having sand into having beautiful vases or glasses or anything like that. And metallurgy. Metallurgy is the study and the transformation of minerals, how we get gold from the soil and all of a sudden it's converted into jewelry, for example, or some other items in new products right now, right? So these are super old. If you study your history, you can see that one of these processes is involved in any of our ancient cultures. The new substances and processes, for example, fabrics. Fabrics right now, more and more of them are artificial. We're not just doing silk or cotton or wool. We have a lot of them. We have nylon. We have this very new and very nice workout fabrics that they don't get wet or they evaporate our sweat very, very fast. All those types of swimsuits, for example, those are new materials. Teflon is super important. We can see it in, the application that we can see right now is obviously in our kitchen, in our Teflon pans, that nothing sticks to it. And also super important for all of our nice smart devices is the semiconductor industry. How do we make things where energy is passed through it very, very fast and very, very efficiently? It says more than 8 million substances have been characterized and produced. So if you see, chemistry is everywhere. So chemistry studies matter and change, and the way that they study it varies drastically. So chemistry is subdivided mainly in these areas. I'm only going to talk about the 5, and I'm not going to even say more important ones. I'm going to say the most common ones. All right. Obviously, chemistry evolves, and we have new areas of chemistry all of the time. So we're going to start with the first one. We have inorganic chemistry, then we have organic, analytical, super important, physical chemistry, and biochemistry. So biochemistry is obviously related to biology and obviously to medicine, right? So that's why it's so important, and people like biochemistry a lot. It's also related to nutrition, it's related to any sports medicine, etc. So let's start with inorganic chemistry. Inorganic chemistry is actually the chemistry that we're going to study this course, and it's usually the first chemistry that we study. It is the area of chemistry that does not deal with carbon. So every other element in the periodic table that is not carbon is something that we're going to see. Some of the applications of inorganic chemistry is catalysis. It deals with catalysts, which are agents that increase the rate of reaction without being consumed. And also it deals with material science, which is the design and synthesis of materials that allow the advancement of technology. So that is what we have with inorganic chemistry. With inorganic chemistry, we deal with the periodic table. We deal with nomenclature, so I'll write it over here. We deal with the periodic table. We deal with nomenclature, the nomenclature of inorganic compounds. We deal with the reactions of inorganic compounds. We deal with stoichiometry. Super important, stoichiometry. It's how actually we go from being chemists into being engineers, right? So all of that is part of inorganic chemistry. On the other hand, we have organic chemistry. So if the inorganic chemistry dealt with elements that is not carbon, organic chemistry deals with all carbon compounds. So it deals with this. It's concerned with looking at the structure and behavior of the molecules of life, which are composed of carbon, hydrogen, oxygen, nitrogen, and some other elements. So usually this is the definition that we learn: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. It says it analyzes and produces different compounds such as drugs, flavorings, preservatives, fragrances, plastics, and fertilizers. So in organic chemistry, we understand how carbon bonds. And because it bonds in many different ways, we see something about functional groups. So we also see about the reactions, obviously, of these functional groups, how they react. Here we see polymerization, because polymers are organic compounds. We see everything related to new products, etc. I have the example here. This molecule is vanilla. It's the actual molecule, it's vanillin. And this is something that we learn also in organic chemistry. We learn how to name organic compounds. So we also deal with nomenclature. For the third one would be analytical chemistry. Analytical chemistry goes hand in hand with all of the other chemistry because it is the identification and quantification of materials in a mixture. So analytical chemistry is all about instrumentation and methods to identify things in a mixture. So for example, how to use the HPLC, how to use microscopes, how to use, ELISA, etc. Right? So it is the quantification of stuff in substances. The other one, the fourth one, would be physical chemistry. It says the study of fundamental physical principles that govern the way that atoms, molecules, and other chemical systems behaves. It also deals with the rates of reaction, so that's called kinetics. It deals with the way light and matter interact, that's called spectroscopy. How electrons are arranged in atoms and molecules, that it's called quantum mechanics. And the stability and reactivity of compounds, that's called thermodynamics. Here we have a picture of how electrons are arranged in an atom. So how electrons are here or here or here, or how they are, that's something that physical chemists will tell us. And why is that important? Because once we know the properties of the elements or compounds that we're trying to react, we can know how to react them. We can know what is a better reaction to get the most out of it. And the last one would be biochemistry. I told you this is a very interesting branch because it deals with biology. And because it deals with biology, it also involves medicine. It also involves nutrition or any nutritional science, etc., right? It is the study of chemical principles underlying basic biological systems. Biochemistry study plants, it studies animals, humans, of course. It studies the link between the structure and function of biological macromolecules. Macromolecules are studied in organic chemistry because macromolecules are polymers of organic molecules. So this is studied in organic chemistry. But if we want to know how these molecules react with one another, we have to study biochemistry. So those are the 5 most important branches of chemistry. And if you see, chemistry is everywhere. It's from what we eat, what we drink, what we wear, what we do, how to get a better life, and that